Hi, welcome to my YouTube channel Education for Aspirants. Today I am going to discuss the concept of postfix expression tree. In this lecture, we will discuss what is an expression tree, then what are the rules to design a postfix expression tree, and at last we will design a postfix expression tree with an example. It is a very important concept for your university level exam or any competitive exam. So that's why you please listen carefully so that it will help you a lot at the end. Watch the video till the end so that you will get all the concepts behind the postfix expression tree. Let's start the session with what is an expression tree first. Whenever we are representing a mathematical expression in the form of binary tree, then such binary tree is called as an expression tree. Let's consider that mathematical expression 5 plus 2 multiplication 3 minus 1. In this mathematical expression, 5, 2, 3 and 1 are called as operand. Similarly, plus, multiplication, minus, these are called as operator, right? Whenever we will represent this mathematical expression in the form of expression tree, in that expression tree, normally the operators will be represented in the form of internal node and the operands will be represented in the form of leaf node. If you will represent that mathematical expression in the form of expression tree, then that expression tree will looks like in this manner. So here if you will observe, multiplication, plus, minus, they are represented as internal node, and 5, 2, 3 and 1 they are represented as leaf node. Now we will move the types of expression tree. To represent a mathematical expression, we are normally using three different type of forms. One is infix form, second is prefix form, third one is postfix form. A mathematical expression can be represented in three different forms: infix form, prefix form and postfix form. So if we will use a binary tree to represent the infix form of the mathematical equation, then such type of expression tree is called as infix expression tree. Similarly, if we will represent a binary tree to represent the prefix form of the mathematical expression, then that is called as prefix expression tree. And the last postfix, if you will represent a binary tree to represent the postfix expression form of a mathematical expression, then that is called as postfix expression tree. So today we will discuss more about the postfix expression tree. Let's start what are the rules to follow to convert a mathematical expression into postfix expression tree. At first, what we will do, whatever the characters will be there in the postfix expression, we will visit all the characters from the left to right. So let's see here, this is the infix expression of a mathematical form. Then the same infix expression form converted into postfix form in this way. So if you will observe here, in the postfix expression form, all the operands are coming first, then it is followed by the operators. So here, before convert the postfix expression into expression tree, we should know that both prefix expression tree and postfix expression tree uses a stack to represent the tree. Clear? So here, by the help of stack, we will convert that mathematical expression into postfix expression tree. So first rule is what? If an operand will encounter in the mathematical expression, then we will push that operand into the stack. Let's take a stack here. Okay. If an operand will encounter, then push the operand into the stack. If an operator will encounter, then what you will do? You will pop two operands from the stack and make the top element as right child of parent node, and second top element is left child of the parent node. Then design a tree between these operands and that operator, and after designing, push that resultant tree into the stack again. So continue this step 1 to step 2 for each character present inside the postfix expression. This is postfix, not prefix. Postfix expression. So now we'll see. First what we will do, we will scan all characters from left to right. What is the first character here? A. So push A into the stack. Why? Because A is the operand. Then B is also operand. So push B into the stack. Then C is also operand. Push C into the stack. Then multiplication came. When multiplication came, then what you will do? You will pop out two operands from the stack and you will design a tree by taking these two operands and that operator. But whenever you are designing the tree, at that time it must be ensured that the top element will come to the right side, means right child, and the second top element will become the left child. So here what is the top element? C. So that's why take that operator as multiplication, parent node, and top element C will become the right child, and B is the second top element, so make B as the left child. Clear? After that, so though you have popped already these two operands, that's why you will remove these two operands from the stack. Then this is the result of this place. Now plus came, so what you will do? This is the top element and A is the second top element. So make a tree or form a tree by using these two elements. So first make plus as the parent node, then you know that the top element will become the right child. So that's why multiplication, then the tree B and C, that is become the right child of plus, and A will become the left child of plus. Clear? In this way, we will convert a postfix expression into its equivalent postfix expression tree. Let's design a postfix expression tree from a postfix expression. So see here, so this is the given postfix expression. Why it is a postfix expression? Because the expression ended with operator, division and plus. That's why that is called as postfix expression. So at first what we will do, we will take a stack, then one by one character we will process from left to right, and whenever a operand will come, then we will push that operand into the stack, and whenever a operator will come, we will pop out two operands from the stack, and with the two operand and that operator we will form a tree, then we will push the tree again into the stack. This is the procedure we will follow. So let's start. We'll take a stack here. First operand is what? A. So push that A into the stack. Then what is the second operand? B. So push B into the stack. Then what is the third operand? C. Put C into the stack. What is the next character? Multiplication. So when multiplication will come, what you will do? You will design a tree by taking these two operands. We will first pop out these two operand and we will design a tree by taking these two operand and that operator. So how that tree will design? Make multiplication as root node, then make B as the left child of multiplication and make C as the right child of multiplication. Why? Because the top element will become the right child and second top element will become the left child. Now we will delete that, and the result of the tree is now this place. After that, what is the next character? Plus. So when plus will come, what we will do? Again we will pop out two operands from the stack and we will design a tree. So if we will pop out two operands, the first operand is the tree and second operand is A. So with these two operands we will design the tree now. So first make plus as parent node, then A will become the left child node, then right child node will become the tree. So that star multiplication left is B and multiplication right is C. Then pop these two operands from the stack because already it has popped. Clear? So this is the result of this place. Now what is the next character? D. So take a stack again. Clear? And this is the result of the tree. Then second place will follow the characters. What is the next character? D. So push D into this place. Then what is the next character? Minus. Minus means what you will do? Pop two characters from the stack. So first character is D and second character is that tree. So design a tree by taking these two characters with minus. So take minus as parent node. Then left side is the tree. So tree, draw the tree here, plus then A. Then right side is multiplication. Then left of multiplication is B. Then right of multiplication is C. Okay. Then right side of the minus is D. Then now pop these two operands. One is D. You just delete that D. Next delete that. The result of this place is this tree now. Now E came. So push E into the stack. Then F. So push F into the stack. Then after that division came. So when division came, what you will do? You will make a tree by taking that F and E with division. Okay. So just design the tree, division. Then left side of the division is your E and right side of the division is F. Then pop out these two operands from the stack. I popped out and the tree is the result of that place. Next what came? Plus. So when plus will come, what you will do? You will pop out two operands from the stack and will design a tree by taking these two operand and plus. So now if you see here, the two operands in the stack is, one is this tree and second is that tree. This is your first tree, first operand, and this is your second operand. So with these two operands, you will design the tree now. So if you design the tree, make plus as root node. Then make this tree right child of plus, division, then E, then F. Then second tree we will replace here. Draw this tree in the left side of plus. So this is minus. Minus right is D. Minus left is plus. The edge it is the same tree I will draw here. Plus left is A. Then plus right is multiplication. Then multiplication left is B and multiplication right is C. Now all the characters completed. Whatever the tree, final tree you have drawn here, that is called as your postfix expression tree. Okay, this is your final postfix expression tree. So again we will repeat what you will do here. First you visit all the characters from left to right. Whenever a operand will encounter, push that operand into the stack. And when a operator will encounter, then pop two operands from the stack and design a tree by taking these two operands and that operator. While designing, you must be ensured that the top element will become the right side of the parent and the second top will become the left side of the parent. Continue this procedure towards the end position of the postfix expression. Once all the characters completed, then whatever the final tree you have, that is your postfix expression tree. So in the next class, we will discuss how to construct a prefix expression tree from a prefix mathematical expression. Thank you.